Hi everyone. In this video we are going to look at some additional techniques for finding the integrals of natural logs. So here we have the integrals of the 6 basic trig functions. All right, and so a couple of these we already know. We know that the integral of sine is negative cosine. We know that the integral of cosine is sine, and then of course the plus c because this is an indefinite integral. The integral of tangent u is going to be the negative natural log of the absolute value of cosine u plus c. Cotangent is going to be sine. So tangent is cosine, negative cosine. Cotangent is sine, natural log. Then we've got secant is going to be the natural log of secant u plus tangent u. And cosecant u will be the negative natural log of the absolute value of cosecant u plus cotangent u. So these are not easily memorized, and somebody had to go along and derive them, and I'm sure there's a long proof somewhere. You could even look it up online if you're interested. But these will be a little bit more difficult to remember, and therefore they're probably not used as often. But at least you will know to go and look them up. All right, so let's try our first example. Let's take the integral of the cotangent of theta divided by 4 d theta. All right, that's a 4. Okay, so I'm looking on here and I see that, but I also see that that is not just u. U is theta over 4, so du would be 1/4 d theta. Okay, fine. So I'm going to add the 1/4 d theta and a 4 to the outside. So when I go ahead then and take the integral of that, I'm going to have the natural log, 4 times the natural log of the absolute value of sine theta over 4 plus c. And that's how that works. So here's another one. Once again, this is the integral of tangent. So if we look down there, tangent x, we'll see that very easily. This is negative natural log, absolute value of cosine x plus c. Okay, so here's our next example. Once again, we've got sine 3 theta minus 1 d theta. And so I didn't put the thing on the screen because we already know this integral, so we're going to split it up. So I have sine 3 theta d theta minus 1 d theta. That was a really curly integral. And so we look here, and we know that u is 3 theta. So I'm going to add a 3 and a 1/3. And this is going to be 1/3 negative cosine 3 theta minus theta plus c. And that's how that goes. Okay, here's another example. And this looks like a good time to use u substitution. So since I've got both tangent and secant in the same equation, I think I'm going to just see if this will work. If I can let u be 4 minus tangent 2x. Okay, and then if I take the derivative 4 is 0. The negative tangent 2x is negative secant squared 2x times 2 dx. So I know I have that in the numerator. I just need a negative 2. So if I add a negative 2 on the inside, I have to add a negative 1/2. Okay, so that would give me 1 over u du. Well, 1 over u is just the natural log, so I have negative 1/2 natural log of, and go back to u, 4 minus tangent 2x plus c. So let's do another one. This is a definite integral, all right? And so once again, you're going to see that we can't have cosine and sine in the same problem. So I'm going to let u equal 1 plus sine x, because I do know I can do 1 over u, du is 0. The derivative of sine is just cosine x dx. So if I rewrite this, I have 1 over u du. So that's going to give me the natural log of u, which is 1 plus sine x, from pi over 4 to pi over 2. Okay, so that's going to give me the natural log of 1 plus sine of pi over 2 minus the natural log of 1 plus sine of pi over 4. All right. The natural log of 1 plus sine of pi over 2 is 1. So 1 plus 1 is 2. 2 is always positive, so I don't really need the absolute value. Minus, then I have the natural log of 1 plus the sine of pi over 4 is square root of 2 over 2, which also is always positive. And so my final answer is, using the quotient rule, I have 2 over 1 plus square root of 2 over 2, which is a constant value, which I could put in a calculator and write a whole bunch of decimals. But that's how that goes. So, take it step by step. We've been doing the same ones over and over again, and you just have to keep your head about you. Remember U substitution and your rules, and you'll do fine. One more example. Let's take a look at something like this. It doesn't have a trig function in it, but what we want to do is take the integral. We want to integrate this function. Okay, so let's rewrite it with an integral. I want to do 2 over the natural log of x, and then times x, and then dx. All right, so let's rearrange this just a little bit. The 2 looks like it could come out as a constant, right? I would have 1 over the natural log of x times 1 over x dx. Well, this suggests possibly U substitution. So what would we let u be? Well, how about we let u be the natural log of x? Du would be 1 over x dx, and then that begins to look a little more familiar. So that if we write this as a u, we would have 1 over u du, and so 2 is, so then the answer would be the natural log of u, which is natural log of x, right, plus c. Now, so if we needed to, this looks really odd, but if we needed to, we could still actually use the natural log rules to change this to a to a definite integral. Like, say for instance, we wanted to find out what it was between 2 and 4. All right, so of course this plus c goes away. This is 2 to 4, and then we would write 2 natural log of the natural log of 4 minus 2 natural log of the natural log of 2. And then if we put that together, we would have 2 natural log of natural log. It's the quotient rule, right? So put these over each other. Well, we know that 4 is 2 squared. So this would be, let me do this, 2 natural log of 2 natural log 2 over natural log 2. Notice that that cancels. And so your final answer is going to be 2 natural log of 2. Whew. Not particularly difficult, just complicated. So anyway, that gives you another one to think about. Lots of techniques that you need to do. And I think that's all for now. So I will see you in class.